Hello everyone. This video is on verifying identities. As I've mentioned before in other videos, there's no real recipe to get you through this. There's some guidelines, but after that it's pretty much practice and just seeing enough of these examples that you start to pick up little tricks and you start to see things that you can do on your own. So these are the only identities that I don't have to prove. And I use this, I call that my toolbox, so you can pause the video and look at these. And then this is what a lot of books will kind of tell you to do or try. Again, you can pause that and read that. So I am going to work on these, a few examples. All right, so the first one is secant negative x is equal to negative secant x. So what I'm going to do, I'm going to use a couple of identities here. I'm going to go from secant theta into 1 over cosine theta. All right. But remember, whatever theta is, you have to keep it the same. So here, I'm going to work with the more complex side and say this is 1 over cosine of the same angle. So just write whatever you see, right? And then now, I'm going to use the other fundamental identity here, that cosine of a negative angle is the same thing as cosine of the positive angle. So I'm going to have 1 over cosine of theta, right? Instead of the or I should say x. Sorry about that. And so now that I have 1 over cosine x, I can say, well, that's secant x. Okay. And now that I've got one side to look like the other, and I only worked with one side, I am done. Let's take a look at our next example. Here, sine squared over cosine theta is equal to secant theta minus cosine theta. All right, so just thinking out loud, either side here would actually give me enough to work with. I tend to like things that are already in sines and cosines that I just can recognize things a little bit better. So I'm going to go ahead and work with this side, but really either one, you know, I could open up this and say 1 over cosine and then minus cosine, and then since I'm subtracting them, get a common denominator and start working that way. But I'm going to go ahead and start here. So one of the things I see is generally behind this is cosine and also cosine. So I want to kind of change that sine squared somehow into cosine squared. And remember, sine squared is 1 minus cosine squared of that angle, right? So I'm going to have 1 minus cosine squared theta all over cosine theta. Okay. And now what I'm going to do is I'm going to split up, all right? This is a fraction. So let me just put this as an aside here. If I had said to you, 7 minus 4 over, I don't know, 15. You could write 7 over 15 minus 4 over 15, right? That's what I'm going to do here. So I'm going to have 1 over cosine minus cosine squared theta over cosine theta, okay? And now what you have here, this is your secant. And of course, this is cosine theta times cosine theta. So some people will do this, they'll cross that out, but you're going to be left with 1 over, you're going to be left with a cosine, sorry. You're going to be left with cosine in the numerator. So indeed, let me go ahead and write that a little bit better. This is 1 over cosine theta minus cosine theta times cosine theta all over cosine theta, right? So let me just kind of get that out of the way there. So now one of these cancels out because it's multiplication. And so now you have 1 over cosine theta minus cosine theta, but that's secant theta minus cosine theta equal. So there we are. We've matched that. Here's another example. So here we have 1 over secant beta minus tangent beta equals, in the numerator, secant beta plus tangent beta. Now, one thing I always suggest is when you're working on these from your textbook or online, make sure you write down everything, like double, triple check that you wrote everything exactly right, because it's so easy to miss just one little thing and you keep working on a problem, working on it, and you never had a chance to begin with because it was written down wrong. So always make sure you do that. Now, over here, I'm going to go ahead and work with this side. It's more complex, and it's going to give me something to work with here. So I'm going to go ahead and express this into terms of sines and cosines. So I'm going to have 1, let me put this really big, there we go. Now notice I exaggerate this so I really know that this is all in the denominator. So I have 1 over cosine beta minus sine beta over cosine beta. Right. Now, the nice thing here is I get to already subtract these because these have the common denominator. So what I'm going to be able to do is say this is 1 over 1 minus sine beta all over cosine beta. Okay. Now, I'm going to go ahead and since this is the numerator and this is the denominator, I'm going to flip and multiply. So I'm going to have cosine beta all over 1 minus sine beta. Okay. Now, if that was a little hard to see, it would be as if I had 1 over, I'll make this up, 2/3. Right. Really what's happening is I'm multiplying by 1 and I multiply by 3/2. That's really what's happening. This is 1, but I do it in such a way that, right, this is happening. So technically what I did here is I multiplied by cosine beta divided by 1 minus sine beta in the denominator and in the same thing in the numerator. So I'll write it out here if you like. Cosine beta over 1 minus sine beta, and then cosine beta over 1 minus sine beta. Right? Basically, I'm multiplying by 1, and this cancels out, and now you have that. So that's why they call it flip and multiply, but really what you're doing is multiplying by 1. All right, we're getting there. Let's see here. So now I have to somehow get this to be a little bit more like that. So let me go ahead and see. I'm going to try something. I'm not sure if it's going to work. But what I need to do is get this denominator out of here. So what I'm going to do, I know that 1 minus sine squared, right, is cosine squared. So what I have here is I'm going to multiply by 1 plus sine beta over 1 plus sine beta. Because now when you do a FOIL here in the denominator, you'll have 1 minus sine beta plus sine beta and then minus sine squared beta, so that the middle terms will cancel out. And so in the denominator, what I'm going to have is 1 minus sine squared beta. And then here in the numerator, I'll have cosine beta times 1 plus sine beta. And of course, I can multiply that out. But let's see here. So now I want to get this as cosine squared. So let me kind of, oops, I think I didn't bring enough paper. Hold on. All right, so now what I want to do is go ahead and write this up here so I have more room to work in. So I'm going to go ahead and distribute cosine beta plus cosine beta sine beta, okay, all over. Now this is going to become cosine squared. Okay. Now eventually we're trying to get to secant beta plus tangent beta. All right, so now I'm going to go ahead and split these off. Cosine beta over cosine squared beta plus cosine beta sine beta over cosine squared beta. So now what you have is this cosine cancels one of these, so you're left with 1 over cosine beta. Plus, and then this one cancels one of these, so you're left with sine beta over cosine beta, which finally leads us to secant beta plus tangent beta. Now it's possible, a lot of times there's many ways to do these problems. I just did it one way and it seemed kind of cumbersome. I suspect that this could have been done a little bit more smoothly and elegantly. All right, but at least I got there. All right, I'm gonna go ahead and stop this and just do more examples in the next video. Thanks so much for listening.